All right, welcome to another episode on prime logic. This is another wider plot problem, geometry problem that I found online. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So we have three squares that are built. So maybe this shape is not perfectly drawn, but these are built in this structure. And then we have a semicircle. The diameter of the semicircle, or the sum of the two bases of these two squares, is 5. What is the total area of these three squares? So our job is to find out the area of this square, this square, this square, and then add them together. So let's start. Let's draw some names and elements so we can easily refer to those. So side of this square is A, side of this square is B, and this is also B, for example. This is also A. Side of this square is C. So, and the diameter is A plus B, obviously, right? So we can say that the side of A plus the side of B equals 5. So that's our first relationship. We can also say that A plus C, so the side of this square plus the side of this square, they all comprise the side of this bigger square. So we can also say that A plus C equals what? Equals B, obviously. Okay, interesting. So let's now draw some lines so that we can maybe form some triangles or something that we can compare some values and form and find another information, so we can substitute in those and then find A and solve for A and B and C. So from this intersection point, let's draw a parallel line here. So parallel to this square, A square, for example, let's draw a line from this corner to this intersection point, and from this corner to this intersection point. Sounds familiar, right? This is an angle inscribed in a semicircle, and this side is a diameter. So based on Thales Theorem, this angle must be 90 degrees. But let me just maybe draw some more, denote some more letters here. So for example, we have A, we have capital B, which is this intersection point, and we have, for example, D, this point, we have E, capital A, this point, and capital G, for example, this point. So we know that this angle is 90 degrees. Angle ABD, based on the Thales theorem, is 90 degrees. This angle is also 90 degrees, right? Because that was the parallel to this side. So if we can kind of prove that triangle ABE, which is this little triangle here, is similar to triangle EBD, which is this right-hand side triangle, we can just easily form some comparisons. But how? So they have one angle that is shared. Both have a right angle, a 90-degree angle. Okay, but what about other angles? So in the biggest triangle, ABD, we can say that this angle, so from the biggest triangle, this angle plus this angle is 90 degrees, right? So these two angles, if we add them together, they are 90 degrees because that's a right triangle. And focus on this smaller triangle. So this angle also plus this angle is 90 degrees, right? So this angle plus this angle is 90 degrees. This angle plus this angle is 90 degrees. So we can say that these two angles are the same. They are exactly equal to one another. So it's solved now. So we found that these two little triangles, they have another shared angle. So in other words, this angle equals to this angle. So these two triangles are similar. Triangle AEB is similar to triangle BED. Okay, so let me just write it down here. Triangle AEB, okay, is similar to triangle BED. Then we can just compare the corresponding sides. So for example, In triangle AEB, we can write that this side AE over BE equals, focus on the right triangle, the right-hand side triangle. The corresponding side is BE over ED. Okay, now let's just substitute because we know those values. AE, what is the length of AE in terms of the sides of the square? So AE, for example, is A minus C because this AG is A, right? And EG is C. So AE is A minus C over BE. So B is the side of the square, it's A. A minus C over A equals BE. What is BE? So BE, okay, which is A over ED. So ED is C plus B or B plus C. Okay, interesting. So now I think from these two relationships, we can solve for B and C and then substitute here. So from this relationship, the first one, B equals 5 minus A. And from this one, C equals B minus A, okay? So B minus A is 5 minus A minus A. So in other words, C equals 5 minus 2A. Now let's substitute this and this into this comparison fraction, then solve for A, because now we have just one variable. So let's continue here. A minus C. So what is C? C is 5 minus 2A. A minus 5 plus 2A over A equals A over B plus C. So B is 5 minus A. C is 5 minus 2A. Okay, let's continue further. Let's just cross multiply. So A squared equals, so this thing times this thing. So 5 minus A plus 5 minus 2A, which is minus 3A plus 10 times, so 2A, 1A, 3A minus 5. Okay, let's just expand further. So minus 9A squared plus 15A plus 30A, and then minus 50. Okay, so let's just bring all the terms to one side. So plus 9 squared and 1A squared is just 10A squared minus, this is 45A, so bring it to this side, minus 45A. This is minus 50, bring it to the other side, is plus 50 equals 0. Then we can divide by 5. So 2A squared minus 9A plus 10 equals 0. So now it's very simple. We can just solve for A. So based on this famous quadratic formula, A equals minus B. So this is A, B, C, but just don't confuse it with this variable here. So X, in other words, X equals, so minus B, which is 9, plus minus the square root of delta, or the discriminant, which is B squared, or minus 9 squared, minus 4. A, it is 2, and C is 10 over 2A. Okay, 2A, which is 2 times 2. Let's just continue further. So 9 plus minus 81. So 4 times 8 times 10, 80. 81 minus 80, it is just 1. So square root of 1 is just 1 over 4. So from this, A is either 9 plus 1 over 10 over 4, which is 10 over 4, which is 5 over 2, or 9, or A is 9 minus 1, which is 8 over 4, and it is 2. But which one is the answer? We don't know yet. So one of them. So obviously A can have just one value. We are in geometry, right? It can't have two values. So for example, from this formula, from formula of C, let's just substitute, for example, the first one. Let's see if it makes sense or not. So we know that C equals 5 minus 2A. So C equals 5 minus 2. Let's just substitute this one, 5 minus 2A. So A2 cancel 1 out, so 5 minus 1, it is 0, which can't be the answer. The answer is not correct. So A cannot be 5 over 2, right? Because in other words, C becomes 0, but we know that this is the side of this triangle. So C cannot be 0. We are in geometry, so everything must be positive. So the only answer is just A equals 2. So A equals 2, C equals 5 minus 2A, or 2 times 2, which is 4, or C equals 1, okay? And then B equals 5 minus A. B equals 5 minus A, which is 2, and it is 3. So B is 3, C is 1, and A is 2. And then the sum of the areas. So it is A squared plus B squared plus C squared, because they all are square. So A squared, the total area, okay, this is the total area, equals A squared, or 4, plus B squared, or 9, plus C squared, or just 1. So 13 plus 1, 14 square units. That's the final answer. I hope you enjoyed this video. So make sure to drop your thoughts and answers in the comments below and solve this problem using a different approach, probably a faster approach, but I try to be as fast as possible. So please don't forget to like the video and subscribe to the channel if you haven't already, and see you on our next video on prime logic.